Hi friends, and a very warm welcome to all of you on this e-learning program. Harshamam welcomes you all in this session. Today, in this particular session, we are going to discuss some out-of-the-box questions. You already know that even in Unit 1, we had discussed few questions that were somewhere outside the box questions. So today's session is really very special, going to come nowhere in exams, but yes, it is helpful for your logical development. Sometimes we don't study for marks, we just study for our development. So let's start on with today's session. So this is think outside the box question. That's the content of the day. You already know that we are doing this type of numerical not for examination purpose, but for the logic drilling in you people. So do cooperate and have a look over here. The very first question. 3 blocks of mass m1 equal to m, m2 is equal to 2m, and m3 is equal to 3m, connected by two strings are placed on a horizontal surface. And that is a frictionless surface. Okay? A horizontal force F is applied, and how is the diagram? It's over here. Over here there is an object which is having mass m. This is m1. Next is m2, and the third one is m3. Force is applied in this direction. This is the surface, which is a frictionless surface. Now there was that the force on m3 will be dash F, B, F by 2, C, F by 3, and D, F by 6. Just try to understand the question. What's the question? The question is, there are 3 blocks, M1, M2 and M3. If weight of this is 10, then this will be 20 and this will be 30 kg. And you can see how they are connected. They are connected by 2 strings. And where they are placed on a horizontal frictionless surface. When the force F is applied over here, on mass M3, what will be the force that they have asked? Overall, if I am applying total force F as F, then what will be the force on only M3? Now, how actually the force is going on? Let's have a look. If I talk on M1, then on M1, this is what is force F acting. M2 will exert some kind of force towards M1. Suppose that is force F1. Let's talk about M2. It's a bit big. On M2, you can see some kind of force on both the sides. Okay? So, suppose this as this much will be the F1 itself, that is fetching it towards itself, and so only they are stationary. Then over here, suppose it is applying the force, say F2. Coming to F3, having mass M3, okay, in this direction the force will be applied by 2, and itself M will be having its own force, that is F3. Okay, this is how on each of and every block the force will be acting. Now, the total acceleration of all will remain same. So, F force is equals to mass into acceleration. Let's find out the total acceleration. If total force is F, what will be the total mass? Force is mass into acceleration. What is going to be the total mass? Total mass is m1 plus m2 plus m3 into acceleration. So what is the force over here? F is equals to, what is m1? It's only m. m2, 2m. m3, 3m into acceleration. So F is equal to m plus 2m, 3m, 3m plus 2m, 6m into acceleration. Therefore, acceleration is F upon 6m. That is the constant acceleration which is getting exerted. So here the total force is F and acceleration is F by 6m. Now tell me what is the formula of force F? It is mass into acceleration. If I am talking about the third one, so force acting on it will be F. Force acting on only m3 is mass of m3 multiplied by the acceleration. What is the mass of the m3? It's 3m. And what's the acceleration? F by 6m. mm will get cancelled out and 3 will go with 2. So, the new force F acting is F by 2. That means, whenever you are pulling over here, because the acceleration is F by 6m, if it is m2, then what would have been the answer? 2m into F by 6m, that is F by 3. So if over here m2 is ours, then it will be F by 3. m1 is ours, then it is F by 6. Okay, I hope you are trying to understand. These are all connected ones. F is connected with m1, m2 and m3. So what happens? If we talk about only m1, then on m1, this is also exerting force and this F1 is also exerting. On m2, force is coming from both m1 and m3. On m3, it is coming from m2. But it is also applying its own force, F3. Okay, because you know the property of inertia. On that basis, it will try to apply its own force. We know that force is mass into acceleration. What is the total mass? The total mass is m1 plus m2 plus m3. That is m plus 2m plus 3m, which is 6m into a. So acceleration is F by 6m. New force F, that is m3 into a. So 3m into F by 6m. 3 twos are 6. So new force F acting will be F by 2. This is really the concept which is outside the box. You have to try to understand this type of questions, try to do this type of questions, and these are the things that are going to help you out. So just note it down very quickly. Be quick in noting it. After you note this, we will continue with the next numerical, which is again outside the box. Be quick. I hope that you have noted this particular sum. Now let's go for the next numerical. This 1 or 2 minutes for you to note the question as well as the solution, because this particular numerical is given nowhere in your book. We have seen the distance versus time graph, displacement versus time graph, velocity versus time graph. Today, we are going to see force versus time graph. You might have never seen that type of graph, and so only we are going to discuss about the same, the force versus time graph. A force versus time graph the force versus time graph for the motion of a body is shown in figure. I'll just draw it for you. Change in linear momentum of it from 0 to 8 seconds is dash. And here is the graph. -2 plus 2 F T. This is time in seconds. And the options are, there are 4 options. Which are those? 0, 4 Newton second, 8 Newton seconds, none of the above. Now this is what is the question given to us. Have a look at it. The force versus time graph for the motion of the body is shown in the figure. Change in the linear momentum of it from 0 to 8 seconds over here. The seconds are, this is 2, 4, 6 and 8. This is how the journey is going. You have to calculate what is the change in the linear momentum. Now I am going to say something, and from that you will get the concept for this. Okay. If it is velocity versus time graph, area under the curve of velocity versus time graph, what does it give? Area under velocity versus time graph gives you displacement. In the same way, area under acceleration versus time graph, it gives you velocity. Just think, what will the area under force versus time graph give? Think. If you have got the correct answer, just send me the answer right now in your WhatsApp. Through your WhatsApp to me. Just try to think. It's totally linked. Totally it is linked. Be quick and think and say. 30 seconds I am giving you, think. I have already given you hint. Velocity is displacement upon time. Acceleration is velocity upon time. That means change. So what will be the area under force versus time graph? 30 seconds are about to get over. Okay. The area under force versus time graph gives the momentum. So here the total area under this graph will give us the momentum. Now how to calculate that? The very first thing that I want to tell you over here is we are talking about force or momentum, which are vector quantities. So that first you have to understand. We are talking about which type of quantities? Vector quantities. Vector quantity needs magnitude as well as direction for its complete description. You have studied that, right? Now over here, in the downward direction, whatever will be the area, same will be over here in the upward half direction. Whatever is the total area in the positive side, same is the total area in the negative side. From this diagram, it's clear that it is clear that area on positive side is equal to area on the negative side. Hence, total area, if you are adding two things which are same in value but opposite in numbers, signs, plus 3 and minus 3, plus 4 minus 4, what will you get? You will get 0. Hence over here, because the total area under force versus velocity time graph is 0, the linear momentum will be 0. You got to know one more thing over here, that is this, the unit. Even the other options explain you lots of things. Another unit of momentum you got. So note down that also. Unit of momentum is Newton second. That is another unit. Okay? So please just note this down. You have to compulsory note it because this is not there in your textbook. Quick. Be quick in noting. After you note, we will do the next particular sum. Be quick. You have just 1 minute to do it. Be quick in noting, you have just last few seconds. If you have not noted, just simply take the screenshot so that I can start on with the next numerical. Okay, 5 seconds for you. 5, 4, 3, 2, 1. Next numerical. That is outside the box. Question number 3. Let's move further. A monkey weighing is not a monkey weighing 20 kilogram slides on a vertical rope. Slides on a vertical rope with the constant acceleration of 7 meter per second square. If the gravitational acceleration is 10 meter per second square, the tension in the rope is dash. This particular question is based on the fact of balanced force and unbalanced force. Okay. What is the fact? The question based on Newton's second law of motion and the concept. Now I'll try to explain you. Here is the rope, and on the rope somewhere over here the monkey is hanging. Okay? This is the rope, and on this rope monkey is hanging somewhere over here. What is the weight of the monkey? The mass of the monkey is 20 kg. and it is sliding on this with the acceleration as 7 meter per second square. Now gravitational acceleration is 10 meter per second square. What is the tension on the rope? First of all, if mass of the object is 20 kg, gravitational acceleration is 10 meter per second square, what is the force which is acting in the downward direction by the Earth's gravity? Force by gravity. What it is? M into gravitational acceleration. What is the mass? 20. Gravitational acceleration 10. That gives you 200 Newton. Where is this 200 Newton acting? It is acting in the downward direction. Okay? Tension will act in upward direction. Now how can we get the tension? We know that how much is the force getting exerted over here? Force on object or on monkey, that is mass into the acceleration with what it is moving. What is its mass? 20. What is its acceleration? 7. That is 140 Newton. So if itself on it the exerted force is 140 Newton, the tension will be m into g minus m into a, that is 200 minus 140, which is 60 Newton. Okay, this is the new concept now. You have, over here I have brought a new concept. How to calculate the tension, and this type of questions are coming a lot in higher exams. This kind of questions are really going to help you out in your NSO especially. NSO, NTSC, wherever you say. Here we are, just again I am explaining you because it's a bit tough numerical. Not tough, but again it's think outside the box. So ma'am needs to explain you. The mass of the object is 20 kilogram. Acceleration 7 meter per second square. The gravitational acceleration downward is 10 meter per second square. They have said what will be the tension in the rope. Tension doesn't mean the tension that generally people are taking. No, it's not like that. Over here tension means whenever anything is getting hanged below, then the upward direction, whether anything, any kind of force is getting exerted. So because of that particular thing, it is trying to hold it. That is the tension of the rope. So what is the force by gravity? It's 200. It is exerting the force of 140. So the tension in the rope will be the left out one, which is 60 Newton, because we have to balance the total force. If over here it's 200, then here also it should be 200 total. This is how the tension is calculated. This type of questions will really help you out for a higher level of exams. Just kindly note it. After that, we'll do the next particular numerical. Be quick. Be quick, after this we'll do the next particular numerical. You have last 1 minute to note it. After that we'll do the last numerical of the day. all the concepts that we have done today. The example before it, that is force versus time graph, was new for you. Then the very first question on how the force is getting divided on each and every block, that was new for you. This concept of tension, again, it's totally new for you. Now next particular question, that is somewhat an easy one, because in the ending we'll end up with a simple numerical. Let's have a look at it. A ball of mass 0.3 kilogram is coming towards a player with the velocity of 10 meter per second. Player kicks the ball with velocity of 20 meter per second in the opposite direction. If the impact lasts for 1/30 seconds, calculate the force involved. Okay, what are the options? 90 Newton, 270 Newton, 0.3 Newton, 135 Newton. This is the question that is given to us. Let's try to understand the question. There is a ball of mass 0.3 kilogram and it is coming towards the player. So here is the ball. It is coming towards the player with the velocity. And what is the mass of the ball? We'll first draw the diagram and also write the given data. Okay? The mass of the ball is 0.3 kg. It is coming towards the player. Suppose here is the player and it is coming towards the player with a velocity of 10 meter per second. So, the initial velocity over here is 10 meter per second. Player is kicking the ball with a velocity of 20 meter per second in the opposite direction. So here the player is, this is 10 meter per second and player is kicking it with 20 meter per second. So the final velocity is in the direction opposite to the initial velocity. Try to understand over here, the initial and the final both are in the opposite direction. So if I am taking u positive, then I have to take v negative. That means it is minus 20 meter per second. If the impact is lasting for 1/30 seconds, that means t is 1/30 seconds. Calculate the force involved. Now how can you calculate the force if mass, initial velocity, final velocity and time is given to you? You just have to simply apply Newton's second law of motion, that is force is equal to rate of change in time, rate of change in momentum. So the same I am going to apply. F is equal to delta P upon T. What is the change in momentum? M V minus U upon T. M is 0.3. What is V minus U? V is minus 20. Can you see over here? V has minus 20. V is minus 20. U 10. Minus sign will remain as it is upon time, which is 1 upon 30 seconds. Okay? Now, how can 0.3 be written as? It can be written as 3 by 10 into minus 20 minus 10. That comes to minus 30. Denominator's denominator. Where will the denominator's denominator go? It will go in the numerator. So again you are having 30 over here. 1 0 will get cancelled out. 3 3s are 9, 9 3s are 27. With 1 0 you have the final answer as minus 270 Newton. So here the correct answer is this, which is minus 270 Newton. Once again, I'll explain you the answer, the question as well as the answer. There is a ball of mass 0.3 kg. It is coming towards the player with some velocity. If I am taking this positive, this I have to take negative. Again, opposite. If I take this negative, this I have to take positive. So ultimately, you will get the same answer, which is 270. Here, negative shows the direction. That means it is the force is exerted in the opposite direction. So do remember that. Most of the time here what happens, student take initial velocity minus final minus initial. So 20 minus 10, that is they'll get 10. So here most of the students think 10 will come and the very first answer 90 they tick. Most of the students do this mistake, but you don't have to do it. Why? Because you have been taught that opposite direction, this is not given for any kind of joke over here. It is having its importance. You have to think why each and every word is given. Sometimes, yes, it is for creating any kind of phobia, but here in this case, it isn't. For in order to think whether it is a phobia question or not, you need to practice well. So, calculate the force that is involved. How we got it on the basis of time rate of change in momentum. What I kept over here, m into v minus u by t. My v is minus 20. Why it was taken minus 20 as I taught you? Because of the direction. So minus 20 minus 10, that comes to minus 30. 0.3 is the mass upon 1 by 30. That went up and we just calculated this as minus 30. We cancel out the 0 over here and we got the answer as 270. Please quickly note it within 1 minute. Kindly be quick in noting. It is really going to help you out. For the brain drilling, only think outside the box will be helpful to you. And it will be helpful to you to the peak. You have last few seconds to note it, and after that, we'll wind up with today's session. Quick in noting. And there is a short information. So kindly be quick in noting it. So I hope that you have noted, and if not, then again I'm going out and I'm giving you 5 seconds. You can take the screenshot of it. 5, 4, 3, 2, 1. Okay. So So that's all for the content of the day. Friends, do remember that think outside the box is really think outside the box. You may think that these things are not going to come in exam, then how are they helpful? Yes, they are helpful because most of you are really born to uplift your brain. Okay, in whichever stream you go arts, you go for arts, you go for commerce, or you go for science. It will ultimately help you out because logic drilling is very much essential. So I hope that you enjoyed today's session and you understood it. That's all for the content of the day. Thank you everyone for listening to me and have a very good day. Bye bye all of you. Bye.